Hello, in this video we're going to learn to verify identities using the fundamental identities. What are the fundamental identities? Well, I've listed them here. The first one we've done since chapter 1, the reciprocal identities. I won't show you how to get those because we've seen how to do those in chapter 1. Cotangent we know is 1 over tangent. Secant we know is 1 over cosine, and cosecant is 1 over sine. The next one is the quotient identities, where tangent is sine over cosine. Cotangent, because it's reciprocal and they're the reciprocals of each other. Cotangent, reciprocal of tangent is what I was trying to say. We know that it's cosine over sine. Let me go ahead and show you the first one. To prove this identity, I'm going to start with sine over cosine and use the definitions of sine and cosine from the very first chapter. And tangent, by the way. Sine theta we know is y over r by definition, and cosine we know is x over r. If I multiply both sides by r to get rid of the complex fraction, the r's cancel and you end up with y over x, by the way, which is tangent of theta. By the way, another way you could have thought of this is y over r divided by x over r. And we know dividing, you multiply by the reciprocal, and the r's could have canceled that way as well. And cotangent could be done a similar way. The next grouping is the Pythagorean identities. The first one we've seen from the first chapter. Sine squared of theta plus cosine squared of theta is 1. This can be proven a similar way. This would be y over r, but we square it. This is x over r, and we square it, starting with the left side. So that would be y squared plus x squared over r squared. But since, if you remember, we're dealing with a right triangle, we should do it over here, right triangle, x, y, and r, we know that this is just equal to, let me do it right here, r squared over r, which equals 1. From the fact that in a right triangle, x squared plus y squared is r squared. So you can see that it does work. In fact, of the 3 Pythagorean identities, this is the only one you really need to memorize because the other 2 are really easy to get. What I'm going to do is start with the sine squared plus cosine squared. Sine squared of theta plus cosine squared of theta equals 1. Okay, so what you're going to do to get the second one is if you divide everything by cosine squared, every single term by cosine squared, what you would get is a tangent squared theta plus 1 equals secant squared theta. Since sine over cosine is tangent, cosine squared over cosine squared is 1, and 1 over cosine is secant, so 1 over cosine is secant squared. And then you would have the second one. To get the third one, you just divide everything by, we'll do it over here, divide everything by sine squared. So we'll start with the first one, dividing everything by sine squared. What do you get? Do you get it? You sure do, because this would be 1 plus cosine over sine we learned was cotangent, so this would be cotangent squared. 1 over sine is cosecant, which, by the way, is cosecant squared. So that gives me the third one. The negative angle identities we won't be going over in this video. So using this, let's go over our first question. This is one of the homework questions. The question is, verify the following identity. And I gave a bunch of hints here. The first hint is learn the fundamental identities, and that is what we've just been going over in the first part of our video. And then the second thing, substitute one of these identities whenever possible. So right now I can do that. I like to try starting with a more complicated side. Now, to me, both sides are just as complicated as each other, so I'm going to go for the first one, but you could do the second as well. I start, if one side is definitely more complicated than the other, then I start with that. So we're going to use one of these identities, and the third sentence here is sometimes helpful to express in terms of sine and cosine. So, well, that secant there, that's blaring out that I should maybe do a substitution. So I'm going to make this a cosine of theta, but instead of secant, I'm going to change this to 1 minus cosine of theta. Always try to simplify, next line, simplify and factor. So I'm going to go ahead and do that. I'm going to multiply. I never like double fractions, so just like I did up there, I'm going to multiply top and bottom by cosine of theta. So what would we have if we did that? Let's do it down here. We'd have cosine square root of theta on the numerator. The denominator, there's a distributive property, that would be 1 minus cosine of theta. Doesn't look like it's helped me. So I'm going to keep on reading. If one side contains more than one fraction, well, it only has one fraction here, but if it did, we get an LCD, so I'm going to skip that for this one. If an expression contains 1 plus or minus sine or 1 plus or minus cosine, then we're going to multiply both sides by its conjugate. Well, we do have a 1 minus cosine, so I'm going to do that trick. I'm going to multiply top and bottom by its conjugate. If you remember, in your past classes, a conjugate means the opposite sign. So we still have cosine, but it's going to be 1 plus cosine of theta. We're going to multiply top and bottom by that. So that looks like it's getting mixed up, so let me move that down. So whatever I do the denominator, if I do it to the numerator, it doesn't change the fraction. And what do I get? Well, in the numerator, notice how I have a 1 plus cosine. That is now looking good. The very last one, I'm going to skip down. As you select your substitution, you should keep in mind the side you're not changing. So really notice what I'm doing is I'm starting with one side. I'm going to use all my identities, and I'm going to try to get to the other side. So one side I'm not going to change because it represents your goal. Okay, so I'm going to try to get to this, and notice I already have that 1 plus cosine. So let's go ahead and write what that is. Maybe I won't put the equals there. That's going to be cosine squared of theta, 1 plus cosine of theta. And because of FOIL, I need to FOIL this out, the middle terms will cancel. So you get the first, which is 1. Notice how the outer is positive cosine and the inner is negative cosine. It cancels. If you remember, that's a minus b times a plus b in algebra, which is a squared minus b squared. So that's why we get minus the last, which is cosine squared of theta. Well, again, let's try. I see a substitution here. I would always should recognize this as sine. Let's scroll down and talk about that. If you remember from the very top here, we know the Pythagorean identities, sine squared plus cosine is 1. Really, this is just another form of that, because if I subtract cosine squared from both sides, I will get 1 minus cosine squared. So you should always recognize this, and 1 minus sine squared, right, is 1 minus sine squared, we know is cosine squared. So it's always good to get these down as well. So I'm going to substitute that in. So what would that be? I'm going to leave the numerator alone and do another substitution. This is equal to sine squared theta. Believe it or not, I am so close, right? Because tangent, right, is in the denominator, so that's like a cotangent, and we have a cosine over sine. So I'm really close. If this is where sometimes I'm going to talk about the note. working with both sides is sometimes a good alternative. I'm not going to do it here, but when identities are difficult, if one side does not seem effective, switch to the other side. So say you're stuck here and you cannot get to that. You can switch to the other side, and somewhere along the way you may have the same expression on both sides. If this happens, pick one side, because again, you want to keep one side alone. You start with one side, you're trying to get to the other. If this happens, pick one side and reverse each step that leads back to the other side. So that is something to think about if you get stuck. But let's not do this because we can handle this. What we're going to do is say, okay, I need to get rid of that cosine. So I'm going to do something kind of clever. I'm going to multiply top and bottom by 1 over cosine squared of theta. So what does that give me? If I scroll down one more time, that gives me that the cosines here cancel in the numerator, so we get the 1 plus cosine of theta. And one of the reasons I did this, because that's all we have in the numerator is cosine of theta plus 1, so we can switch that around at any time. This would be sine squared theta over cosine squared theta. That's one of our fundamental identities. That is tangent of squared of theta. And just to get this looking exactly like our original, you can see we have just cosine theta plus 1, and I have to scroll back and forth, over tangent squared of theta. We did it. Last thing to talk about is a caution. The caution. The procedure for verifying identities is not the same as that of solving equations. If you notice, I did not add or subtract the same quantity from each side. So you can't multiply both sides here or cross multiply or multiply both sides by the same quantity, right? Because yes, they are equal and you will get them to be equal. But when we verify identities, you want to start with one side, just like I did. I started with the left. Use your identities, substitute, do all kinds of algebraic tricks until you get to the right side. Hope that helps.